Hello, you guys. Hello, how are you? All right, so we're going to start on their review. Um, and there's 15 questions on this review. If you guys make sure that you take your notes, like I asked, please make sure you email them to me. Make sure you write this down. S.A. Hamblin at fcps.edu. Okay, make sure that you write this email down so you can email this review to me. Okay, I'm not asking for you. What you should do is you should number your paper number one, draw your triangles, show me the math, and that's it. Okay, I'm not looking for everything to be perfect. You don't have to copy down the actual question, right? Just draw whatever the triangles are, label it number one, draw the triangles, and then I can check it. Okay, so we're going to go ahead and get started in this review. So it says, question number one reads, what postulate or theorem, if any, proves that the triangles are similar, right? And so remember, there's three ways that we're trying to prove these triangles similar. We can either choose angle, angle, side, 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 or side, angle, side. When we see three sides of a triangle, right? 1, 2, 3, that means that we're going to be going for side, side, side. It doesn't mean just because there's three sides that for sure they're going to be similar. It means that this is what we're going to be trying to prove. All right. Anytime that we have three sides, we also know that we're going to use the baby, mom, and dad method. So I'm going to identify my babies, my mom, my dad, my baby, my mom, and my dad. Then I'm going to set up my proportions. Okay, so I'm going to do my baby with my baby, my mom's with my mom's, and my dad's with my dad's. Whatever triangle you start with, let's say this is the smaller one, this is the larger triangle. So we're going to do small on top with the large on the bottom. So all small triangles go on top, all large triangles go on the same bottom. You have to follow the same order. So we're going to do 6/8, and then for my mom, we have 9/12, and then for my dad, we have 12/16, all right? And so once you set these up, what you're going to do is you're going to do the work of dividing these to see if indeed they're all the same. So 6 divided by 8 is 0.75. I'm going to leave it up to you guys to figure out the last two so you can decide if they are indeed side, side, side. So if all three of these decimals come out to be the same, then you can say that there's a side, side, side similarity theorem. Okay? If these do not come out to be the same, then you can say the triangles are not similar. You know what? I'm going to go ahead and do this one with you so you can see it, but then the other ones, I'm going to have you guys work them out a little bit. Okay? So the first one was 0.75, so 9 divided by 12 gives you 0.75. And then 12 divided by 16 also gives you 0.75. So we can say indeed that these are similar using the side, side, side similarity statement, okay? Perfect. All right, let's go on to question number 2. Question number 2 reads, in the diagram below, AD and AC intersect. Now remember, anytime that you see the word intersect, that means they make an X, then we automatically know that we have vertical angles. They're telling us that these two lines intersect to make an X, which means they're going to be vertical angles. Ooh, vertical angles, there you go. So vertical angles at B. And it says that angle BEA, so let's do BEA. Remember, when you have three letters, your middle letter is your actual angle they're referring to, is congruent to angle BDE. C. Remember, your middle letter, if there's 3 letters, is your actual angle. So they're saying that angle A, I'm sorry, BAE, right? So BAE, so they're saying angle A is actually congruent to angle D. So now they said, which of the following can be used to show that triangle ABE is similar to triangle DBC? So as you know, we have to prove triangles similar using one of the following: angle, angle, side, 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 or side, angle, side. So since there are no side numbers on the side of these triangles, we automatically know we can't use side, side, side. We can't use side, angle, side. And since we have 2 angles in these triangles that are congruent, that are yellow, and 2 angles that are congruent, that are red, we know that we can prove these 2 angle, angle. All right, let's move on to number 3. It says, are the triangles similar? If they are, write the similarity statement and give the similarity ratio. So given that angle R is 32 degrees, so I'm going to write this in blue. So angle R right here is 32 degrees, right? And then angle U is also 32 degrees. So I'm going to write this out again. There's 3 ways that we can prove: angle, angle, side, 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 and side, angle, side. Now remember, if we do side, angle, side, your angle has to be in between your 2 sides. So let's look at what we have. I see 2 sides of a triangle here. So there's 2 sides that we have, which means that we're going to try, and I even see an angle, right? So we're going to try to prove it side, angle, side. So the first thing I'm going to do is, without even setting up my ratio, I notice that my angle here, right? I notice that my angle here is not in between, is not in between my 2 sides. So I have an angle, a side, and a side. But I do not have a side, an angle, and a side. So can we prove that these 2 triangles are similar? The answer to that would be no. And I want you guys to see why. Your angle is here, your sides are here and here. In order for it to be proven side, angle, side, your angle would have to be in between side 12 and side 18. Your angle is not in between 12 and 18. The angle is over here outside of 12 and 18. So I have an angle, a side, and a side. And as you can see, that's not an option here. We don't have an angle, a side, and a side. We only have a side, an angle, and an angle. So for question number 3, the answer to that would be the triangles are not similar because you cannot prove them to be side, angle, side. All right, so for question number 4, it says the triangles are similar. Find the value of the variables. All right, so they want us to find the x and they want us to find the y. All right, so this is where your order matters, right? Let me get my highlighter going here. I'm just going to highlight a couple things here. So I noticed, looking at these 2 triangles, there's no similarity statement here for me to do color coding, right? So I don't have a triangle ABC is similar to triangle DEC. And so I'm looking at these triangles and I'm looking at the markings of these triangles, and that's what we're going to use to set up our proportions, right? So I see here there's a 90-degree angle and then there's an angle mark right here. So I'm going to highlight this yellow. So I'm going to look for the same side on this triangle. It's a 90-degree angle here and like a little angle marking. So I'm going to highlight this, right? Then I know that this side right here, there's nothing. Starting at the 90-degree angle, there's nothing. I'm going to highlight this one blue. And I'm going to highlight the same side here, blue. And then I'm going to highlight this one right here, purple. And I'm going to highlight the same side here, purple. Okay, So let's see what we can find. Let's do the work. All right, so we're gonna set these up. So I'm gonna put my yellow, actually I should probably should have kept my highlighters. So I'm gonna put my yellow with my yellow. I'm gonna put my blue with my blue. All right, so I'm gonna do the yellow with the yellow. So that's gonna be 8. I'm starting with the small, so that means my small is on top, my large is on the bottom. So this is the small one. This is my small triangle. This is my large triangle. So my small is on the top, large is on the bottom. So my yellow with my yellow is X. My blue with my blue, so I'm going to do 6/9. And then for this one right here, it's Y, right? And then there's nothing here. It's absolutely nothing. So I'm just going to leave that one blank for right now. So for right now, what I'm going to do is I am going to cross multiply with what I have. And remember what I said, I'm going to take these two right here. There's a variable here, and there's 2 whole numbers here. So I'm going to cross multiply these, right? So if I cross multiply these, that's going to give me 6x. If I cross multiply these, that's going to give me 72. And then I'm going to do the work, and I'm going to divide it. So that's going to give me 12. So I found out that my x is 12. That's how I would do it the long way, right? I multiplied 6 and x, that gives me 6x. I multiplied the 8 and the 9, which gives me 72. I divided by 6, and it gave me x. What you also could do, if you want to use Desmos, I'm going to write it right here. You can put this into Desmos. 8x equals 6/9, and it will give you x equals 12. So you enter this into Desmos, just like this. All right, so now I'm going to look at my answer choices to see which of these give me x equals 12. So I look at A, that's 5.3, that's not it. I look at B, x is 10, that's not it. I look at C, x is 11, that's not it. And then I look at this one. This is the only answer that has x equals 12. So I am going to go with answer D without even having to solve for y. Do you see how I did that? Okay. Let's move on to question number 5. So question number 5 says, which value of x will prove that triangle LMN is similar to triangle ABC? Ha! Now we get into the wonderful stuff that we love, which is color coding. So we're going to do, hold on, let me write this. So we're going to do color coding. Why? Because we have a similarity statement. Also, some of our sides have variables in them. So I'm going to underline the first 2 letters yellow. I'm going to underline the top 2 letters in red. And then I'm going to do a purple hook for the last 2 letters. Well, the first letter and the last letter, okay? Then I'm going to go down here and I'm going to set this up. So I'm going to have yellow, red, and purple. All right, so I'm going to start with this. Let's say this is my small triangle and this is my large. So I'm going to start with my small on top. Sorry, you guys. I'm going to start with my small on top and my large on the bottom. So I'm going to LM, right? LM is my small triangle. I need to write down what that side is, and it's 8. Then I'm going to go to LM in the second triangle. I'm sorry. Then I'm going to go to AB. Sorry, AB in the second triangle, and that's going to be 12. Then I'm going to go back to the first triangle, MN. MN is 12. And then I'm going to go to BC, and then my BC is 4x plus 2. Now I'm going to do my purple hook, LN. LN is 10. And then I'm going to do my purple hook, AC. AC is 15. There we go. So now we set up our proportions based off of our color coding. So now we need to solve. So it's asking us to prove, it says which value of X will prove the the triangle LMN is similar to triangle ABC. So really what they're asking us to do is they're asking us to solve for our X. So in order for us to solve for X, we have to cross multiply. Now remember, when we have 3 proportions set up, we can't cross multiply all 3. We can only cross multiply with 2. Since the yellow is 2 whole numbers and the purple are 2 whole numbers, it will not matter which ones you cross multiply with. I will show you what I'm talking about. I'm going to take the red and the yellow and the red first, and I'm going to cross multiply. So let me rewrite this down here so that you guys can see. You're going to get the same answer. You can only do this with a whole number. So when there's a variable, you can only cross multiply with a proportion that has whole numbers, right? So this is 8 over 12, and this is 12 over 4x plus 2. So let's cross multiply these and see what we got going on here. So we're going to do 8 times 4x plus 2 equals 12 times 12. I'm not going to say the wrong thing here. I know this. Yeah, because it's the square root, 144. Okay, so now what I'm going to do is I'm going to distribute, right? I have to distribute what I got here. So 8 and 4 is 32x. 8 and 2 plus 16 equals 144. If you entered this into Desmos right here, I'm putting a box around this. If you entered this into Desmos, you should have the answer. You can even enter this into Desmos. And you'll get your answer. But I'm going to keep working this longhand so you can see it. So what I'm going to do is I'm now going to do a -16 and a -16. And so I'm going to do a 32x equals, all right, so I have to do the math. Give me a second. 144 minus 16 is 128. Right? So then we're going to divide by 32 on each side. 128 divided by 32. And lo and behold, guess what? X is 4. So this is with my yellow and my red. I could have also chosen my purple. Let me show you what that looks like. So I'm going to do my red. And I'm going to do my purple. And guess what? Because your purple and your yellow have 2 whole numbers, and there's no variable in them, it doesn't matter which one you choose. So 12, this is 4x plus 2, this is 10 over 15, right? Yeah, 15. All right, let's do the math. So we're going to cross multiply. So we're going to do 10, 4x plus 2 equals, I have to do the math, 12 times 15, that's 180. So now we're going to distribute. So this is going to be 40x plus 20 equals 180. Now remember, if you put this into Desmos or you put this into Desmos, you will get your answer. Okay? So now we're going to subtract 20 from both sides. 40x equals, right, 160. We're going to divide both sides by 40. X equals 4. And you can see we got the same answer for both sides. Okay? All right, so let's go on to question number 6. So question number 6 reads, given that triangle ABC is similar to triangle LMN, What is the length of AC? So they want us to find the length. I'm going to highlight this so that you guys can see this. They want us to find this length of AC, meaning they want us to solve for X, then plug it in. Okay, so guess what we get to do here? We get to rewrite these. Triangle A, B, C is similar to triangle L, M, N. So we have yellow, yellow. We have red, hold on. We have red, red, and we have purple and purple. All right, so we have, I'll do the math right here. So we have yellow, we have red, and we have purple. All right, so now we're going to go to AB. So what is AB? AB is 5. And so we're starting with the small triangle on top and the large on the bottom. So that means we have to keep that consistency all the way across. LM is 10. For our red, which is BC, BC is X plus 4. MN is 3X plus 1. Our purple here, AC, is X plus 5. And then LN is 3X plus 3. Now remember what I said. There's 3 of these. We cannot cross multiply all 3 of them. We cannot cross multiply your purple and your red because there's variables in your red and variables in your purple. Plus, we need to find AC. So if we go back to AC, that's X plus 5. So X plus 5, this is AC. I'm going to put a little mark over here. So that means that we need to multiply our purple with our yellow that has 2 whole numbers. So I'm going to scooch down a little bit and I'm going to rewrite this with the yellow and the purple. So 5 over 10, and then X plus 5, and then 3X plus 3. And so we're going to cross multiply these. So we're going to start here where we have 5, 3X plus 3 equals 10, X plus 5. And then what do? We have to distribute, distributive property. We have to distribute, okay? So this gives 3 times 5 is 15X. 5 times 3, 3 times 5 is 15, equals 10 times X is 10X. 10 times 5 is 50. So now, what do we have to do? We have to move our X, one of our X's. So I'm going to move the smaller X's. That's my 10X. I'm going to move it. This crosses out. This leaves me with 5X plus 15 equals 50. Now I'm going to move my 15. This positive, I make it a negative. This cancels out. So now this is 5X equals, right? And what does that give me? So if I do 50 minus 15, it's 35. And then I divide by 5 on both sides, right? And then that gives me 7. And as you can see, that's not an answer choice here. You got to go back and read what they're asking us to do. They want us to find the length of AC. So if we go back to AC, we realize that AC is 7, or X is 7, but they want us to plug the X in plus 5. So what if we were to plug in our X, which is 7 plus 5, what does that give us? 12. So AC equals 12. All right. Let's go to number 7. So it says, which group contains triangles that are similar? So I'm going to scroll down real quick so that we can see what all of the triangles look like. We have A, we have B, we have C, we have D. Okay. So let's start with A. If we look at A, they want to know if any of these triangles are similar, and there's no way that these triangles can be similar. One, because this triangle has all sides. These triangles have angles, but these angles aren't even the same, so none of these triangles in this group are similar. There's nothing in common between any of these. They don't share sides, they don't share angles, nothing. Okay? So then let's go on to this one right here. So they're looking, do any of these look similar? So is this triangle similar to this triangle? Absolutely not. They are not. Is this triangle similar to this triangle? Absolutely not. We don't know. We don't have any side lengths. We don't have any angles that indicate that any of these triangles can be or could be similar, right? So we don't have enough information to determine that. So the answer to that is no. Now let's look at this one. These are 3 triangles in one, but there's something that each one of these triangles have. First of all, it looks like they all share this angle right here. Right? They all share this angle right here. They all share the tip angle, and I probably can redraw this so that you guys can see exactly what I'm talking about. So this is the small one. It has the tip of that triangle. This is the medium one. And then this is the large one. So what do we know about these triangles here? They all share the tip of this triangle right here. What else do we know? Each one of these has a what? Each one of these has a right angle, which means that these can be proven similar using angle similarity. Do you guys see that? It's hard to see it when it's all in one. It's easier to see it when they're separated. And each one of these triangles share this angle right here, this tip angle. All of them are the same. All right? So the answer here would be C. All right, let's go to number 8. Number 8 says, given triangle LMQ is similar to triangle LNP, therefore, and so I believe we went over this for our review for our quiz. So what are we going to do? We're going to do a color coding. We're going to do color coding so we know how to set up our proportions, right? So I'm going to redraw the similarity statements here, or rewrite them just so they're a little bit bigger. So I do yellow with yellow, red with red, purple with purple. All right. So yellow, red, purple. All right, so what about our yellow? Our yellow, LM, there's no side length, so we're just going to write LM. So I started with the first triangle here, and this is the second triangle. So my first triangle goes on top, and my second triangle goes on the bottom. So I'm going to put LN. I'm going to take my red, which is MQ, put it on top of NP. My purple, which is LQ, on top of LP. Okay, so now I'm going to look at my answer choices and see which of these line up with the order in which we set up these proportions, meaning that whatever order they started in first always remains on top, or second always remains on top, and so on and so forth. So let's look at what we have. Let's look at number 1, LM and MN. Are they the same color? So if I look, I see LM is yellow, right? And then I see MN. Is there even an MN? Is there MN together at all? I don't see any MN at all, right? So I automatically know that can't be an answer choice. Let's go to this one. What about LN? So I see an LN. What about LM? I see that. So they're the same color. So what I'm going to do is I'm going to mark this as being the same color. All right. Now I want to look at the order in which they put them. So LN is for my second triangle. So I'm going to put 2 on top and 1 on the bottom. So the first triangle's on top, the second triangle's on the bottom. Now let's look at this second set. We need to determine if it's the same color. And if it is the same color, then we need to determine if it's in the same order, meaning that triangle 2 has to be on top. Whatever this is has to be on top. It has to be triangle number 2. And the bottom has to be number 1. NP is red, and then MQ is also red. Perfect. So now I need to see, is NP from my second triangle? It sure is. And MQ is from my first triangle. So the colors checked out, and then the order also checked out, and the colors checked out for this one as well as the order. So B is your answer. All right, let's go on to number 9. So for number 9, it says, when standing upright, Gary knows his eyes are 6 feet above the ground level. To determine the depth of the well, he stands in the position shown. It says, using the given measures, how deep is this well? Right? So they want to know how deep it is. So I'm going to highlight this for you. They want to know the depth. So they want to know how deep this is, right? And if they're asking us to solve for it, that means that there's an X here. And so they want us to set up our proportions. And how do we set up our proportion? We do our base with our base and our height with our depth. So I'm going to set this up like this. So I'm going to start with the small. This is my small. This is my large, right? So my height here is 6. So I'm going to do 6 over my, what would be is my depth right here, right? Which is X. And then I'm going to do my base, which is 2 over, what's the base here? But my other side here, which is 6. All right. And then I'm going to cross multiply. Sorry. So then I have 2x, and 6 and 6 is 36. And then what do? I'm going to divide each side by 2. And then once you do that, you will find your answer. I think I'm going to let you guys go ahead and solve for that one. All right. So let me color code these for you one more time, just so that you have it. So this right here is the same as this. This, which is your side, but what is the base right here, is also the same as this. And so we're matching the correct sides of the triangle in proportion. So we did 6, right, with the small on top and the large on the bottom. So 6 right here, small, with my yellow here, which is X. And then I did my 2, right, my small triangle first on top with 6 right here. And then I cross multiplied those. Question number 10. So it says, John is 6 feet tall and standing 4 feet from a tree. If John's shadow is 12 feet long, how tall is the tree? So there's 2 different triangles here. All right. And I'm going to show you. I'm going to do the small triangle here. And then I'm going to do the large triangle here. And like that. Hold on. Okay. So if we look at the small triangle is this part right here. So this is 12 and this is 6. If we look at the large triangle, this is x, and then this is 4 plus 12, which is 16, okay? So now we're going to set up our proportion so they match. So this side goes with this side. This side goes with this side. This is my small, this is my large, right? So I'm going to do my small and then my large on top. So I'm going to do 6 over x, and then I'm going to do 12 over 16, and I'm going to cross multiply. So I have 12x equals, hold on, I got to do this mental math. So 6 times 16, 96. There we go. 96. We're going to divide by 12. And then there you get your answer. Okay? Because it looks like they want you to solve for x. Yeah, they want you to solve for x. All right? There you go. Question number 11, Public Works personnel wanted to find the distance across a water retention pond after a recent storm. They chose to measure indirectly, creating the situation shown in the diagram. What was the distance across the pond? So once again, these are two separate triangles. I'm going to separate them. I'm going to put the small one first. Okay, so I'm going to label what I have. So this is a 90-degree angle. I know that this is 49. Sorry, this small triangle. This is 49, right? And this is 28. My large triangle, this is x. And this is 147 plus 49 for the large one. So that's going to give me 196. So what we're going to do is we're going to match them together. So we're going to do my sides with my sides, and then my bottoms with my bottoms, right? And I'm going to do my small over large. So small over large, right? And so I'm going to have 28 over x equals 49 over 196, and I'm going to cross multiply. So 49x equals, I can't do the mental, let me not say can't. There's no such thing as can't. But let me not. 5,488. All right, we're going to divide it by 49. So when you divide each side by 49, x equals, and then you'll get your x. Okay, so that's how you solve this one. Question number 12. So we have 15. We're almost done. A boy knows that his height is 6 feet at the time of day when his shadow is 4 feet. A tree's shadow is 24 feet. A tree's shadow is 24 feet. Sorry. So what we're going to do is we're going to match it. What is the height of the tree? So we want to know what is the height of this tree. So I'm going to match what I know. My height goes with my height. And the bottoms go with the bottoms. This is my small. This is my large. I'm going to put my small on top of my large. So my small, I'm going to do height with height. So 6 over x, and then I'm going to do bottom with bottom equals 4 over 24. We're going to cross multiply. 4x equals 6 times 24. And so that's going to be 144. And we're going to divide each side by 4. All right. This is number 12. There you go. So do the math. Here, get your answer for that. All right, number 13. So number 13 says triangle ABC and triangle DEF are similar triangles. They are similar triangles, right? So if these are similar triangles, then that means that these angles are corresponding angles, right? So that means that angle A corresponds with angle D, angle B corresponds with angle E, angle C corresponds with angle F. So it wants to know, what is the measure of angle E? So this is the best way that we can do this. Give me 1 second. So the first thing I'm going to do is I'm going to find the third angle in this triangle right here, right? Because if I find all 3 angles in this triangle, I know that my angles are going to be corresponding with this triangle right here. So I'm going to do the math. So to find the third angle of a triangle, I need to do 40 plus 30, right? So when I add 40 plus 30, and then I subtract that from 180 because I know that all my angles of a triangle add up to be 180. All right, so this is 110. Very good. So now I know all of my angles here. So what I'm going to do is I'm just going to highlight these. Let me highlight them. It will be easier if I do that. So my yellow angle is going to be corresponding with angle A is going to be corresponding with angle D. Angle B is going to be corresponding with angle E. Angle C is going to be corresponding with angle F. Okay, do you see that? So they want us to find the measure of angle E. So angle E is green. Angle E is green. So I need to find the other green in this triangle here, which is B. So I know that they're corresponding, meaning that they are going to be the same exact. So I know that my angle E is 110. Does that make sense? All right, going on to 14. So it says, which additional piece of information would prove that triangle IJK is similar to triangle LMN? So we need to figure out which piece of information will help us to figure this out. So I'm going to do color coding. Triangle IJK is similar to triangle LMN. I'm going to do yellow and yellow. I'm going to do red and red. I'm going to do purple and purple. All right, and so I'm going to do red. I'm going to do yellow. I'm going to do purple. All right, so my yellow, I to J, is going to be 10. So this is my first triangle. This is my second triangle. L to M, we don't have anything there. That's an X. So then we're going to go to the red, which is J to K. So J to K is 12. And then M to N is also X. And then I to K is 8. And then L to N is 12. So let's go back in the bottom part of this. So this is L, M. Uh-oh. So this is LM, just so we can remember. And then this one right here is MN. Okay? So now what we're going to do is we're going to solve for MN and see what we get and see if our answer choice is there. If not, then we're going to solve for LM and see if our answer choice is there. But remember, we can't cross multiply our red and our yellow because they have two variables in them. We can only cross multiply with a proportion that has two whole numbers. So we're going to do red, we're going to do purple. All right, so 12 over x, x over 12, 8x equals 144. We're going to divide each side by 8. And remember, this is your MN. So what is 144? What is, so this is 18. So that means that this is 18. So my MN or NM, MN or NM, it doesn't matter which order you put it in, is going to be 18, right? And it looks like that's the answer right here. N to M or M to N, it doesn't matter, is 18. So that's going to be your answer right there. We only had to solve for one of them to find the answer, which is great. All right, 15. Uh-oh. 15, here it is. So it says, which postulate or theorem, if any, proves that the triangles are similar? So let's look at what we have. The first thing I see is a pair of x's, which means that we have vertical angles, right? Then I want to go to this one. This is my small angle. This is my small triangle. This is my large triangle. So I'm going to set up my proportions to see if they come out to be the same. So I'm going to do my small with my small, my large with my large. I'm going to highlight these for you. So this is my small from the small triangle, and this is my small from the large triangle, right? This is my large from the small triangle. This is my large from the large triangle. Now let's set it up. So I'm going to put with my small on top, large on the bottom. So 4 over 10 and 8 over 14. So now we get to do the good work. 4 divided by 10, 0.4. 8 divided by 14, 0.571. So can we prove these two triangles similar using a side, an angle, and a side if these two proportions are not the same? You guys should know the answer to that. And then you guys can pick the correct answer below. All right. And that's it, you guys. It took a little bit longer than anticipated, but still, class is 80 minutes, and this is only 48. So you guys, we saved some time for you guys. All right, so make sure you do the review. Make sure that you send this to my email, please. All right, make sure you send it to my email. All right, thank you guys. I'll see you guys next week on Tuesday. I think that's March 2nd. Is that March 2nd? Oh my goodness, it's March 2nd. I'll see you guys on March 2nd. All right, bye.